Welcome back, everybody. Today we're going to continue our unit on triangles and their properties by talking about inequalities in a triangle. Okay, now when we say inequality, we're talking about greater than, less than, greater than or equal to, less than or equal to, the whole alligator eats the bigger number thing. Okay, and what we're going to do is we're going to use some inequalities to look at how sides and angles of triangles relate to each other. Okay, so here we go with that. So first thing I've got for you is a theorem. Okay, and it says that if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. Okay, so if I have triangle XYZ here, and XZ, so the side in red, is greater than the length of XY, the side in blue. So again, it's pretty easy to tell that red is bigger than blue here. Okay, then what we're saying is that this angle opposite red, so as an angle Y, will be bigger than the angle opposite of the blue, which is angle Z. Okay, so essentially what we're saying there is that the bigger sides are across from the bigger angles, smaller sides are across from smaller angles. Which makes sense because as my angle gets bigger, if we're thinking this is a triangle, okay, between the tips of my fingers, there we go, we're in there, the bigger the angle gets, the farther that distance gets. The smaller the angle gets, the smaller that distance gets as well. Okay, the next theorem just says basically the opposite, relating angles to sides rather than sides to angles. It just says that if two sides of a triangle are not congruent, then the longer side lies opposite the larger angle. Okay, so once again, if I have two angles of a triangle, one's greater than the other, okay, so here we're saying that angle A is greater than angle B, then the length of BC, the side across from A, will be larger than the length of AC, the side across from B. So again, in a triangle, bigger angles are across from bigger sides, smaller angles are across from the smaller sides. So let's take a look at a few different types of questions we can answer based on that theorem. First one, problem 1 says, order the angles from smallest to largest in the triangle. Now we're given a triangle, and we're actually not given any information about the angles. We know what all the side lengths are. Okay, so what we can do is use that theorem to order them smallest to largest, largest to smallest. And I'm going to write that down just to make sure I don't get the question wrong, because I do smallest to largest like I just said. Don't confuse the order. Okay, so running through this, if we want the largest first, what I'm going to do is I'm going to look for the longest side, which is the length of 62, that's this AC. Okay, that means that the biggest angle is going to come across from it, angle B. Okay, next up, I'm going to do the smallest next. Smallest side here is 47, meaning that the angle across from it is going to be the smallest angle, so angle C. And then in between, we've got the 55. Okay, 55 is the middle length, therefore the angle that's across will be between angle B and angle C as far as this measure goes. Okay, so if we know the angles, if we know the sides, we're able to figure out how the angles relate to each other. All right, in problem 2, we're going to do the opposite question. Here we'll use the angles to figure out how the sides relate to each other. So in problem 2, it says order the sides from shortest to longest. Now the trick with this one is, notice I don't know all three of my angles. I'm going to want to figure out what that missing angle, angle T, is first. So we'll say angle T is equal to 180, the total for a triangle, minus the two angles I know, so minus 58, minus 62, which will give us a 60 degrees for a total. Okay, once I know that, once I know all my angles, I'm going to be able to relate the sides to each other. Okay, here we want to go shortest to longest. And it's the same idea. My biggest side is going to be across from my biggest angle. Okay, 62 is the greatest angle here, angle V. Therefore, it's going to be side TU will be the biggest one. And whoops, pay attention, I want to go shortest to longest, so we'll put that at the bottom here. All right, smallest side will be across from the smallest angle. 58 is the smallest angle. Therefore, TV is my smallest side. and then 60 is in the middle as far as the angle goes, so that side will fall between the TV and the TU. Okay, so UV will be by middle side length. Okay, problem B is the same idea, so why don't you pause the video, work through that one, and then hit play to check your answer. All right, same idea for part B. We want to order the sides from shortest to longest. First thing we're going to need to do once again is find the missing angle of the triangle. We can say that angle M is equal to 180 for the sum of all the angles in the triangle, minus the two angles we know, so minus 51, minus 64. That'll give us a 65 degrees. And then we can go shortest to longest. Okay, and we know that 51 is the smallest angle, therefore side length LM or ML, order doesn't matter. We'll say LM is the shortest side. 64 is the next biggest angle, therefore MN will be the next longest side. And then finally the 65 we just found is the biggest angle, therefore LN will be the largest side. Now the other theorem we're going to talk about today is going to use inequalities to give us ranges of possible side lengths for triangles. Okay, we're going to call it the triangle inequality theorem, and it just states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so if I have my triangle here, what this theorem is saying is that no one side can be bigger than the other two. If I look at all the combinations of two sides added together, such as xy plus yz, here's side xy, here's side yz, those two sides added together have to be bigger than zx. Okay, and the other parts are just different combinations of those sides. Now, why is that true? Let's say that if I laid xy down and zy down and they weren't bigger than that third side, the xz, well, what's going to happen then when I go to actually make my triangle, those two sides aren't going to reach each other. Okay, we can't actually connect. Okay, so when it comes time to build a triangle, you can't pick any sides you want. You need to make sure that there's no one side greater than the other two. So as far as questions we can answer then, we can look at whether or not a set of side lengths can make a triangle. So problem 3 part A says, can a triangle have sides with the given lengths? 3, 7, and 8. Okay, I'm going to say that in this case, yes, they can. Okay, because 3 plus 7 is greater than 8. We also know that 7 plus 8 is greater than 3. Okay, and 8 plus 3 is greater than 7. Okay, so now for a problem like this on a test or a quiz, you don't necessarily need to show all this work. You just need to kind of check these in your head. What I'm looking to do is I'm looking to make sure that there's no one side that's greater than the other two combined. Okay, that's not the case. That's why we can say yes, this one is a triangle. Part B, same idea. Can you have a triangle with the sides of the given lengths, 5, 10, and 15? I'm going to say in this case, no, you can't. Okay, because 5 plus 10, the two shorter sides, are not greater than 15. Okay, this is a false statement. They're greater than or equal to 15. But with our triangle inequality, what we need to have is strictly greater than. If they're equal to, we could put them together to make a line, but as soon as I open those lines up to make a triangle, they wouldn't reach each other. All right, so that's why this one is a false. Okay, or a no, because we're not strictly greater than. All right, there is a part C and D to this problem as well. I want you to take a minute, pause the video, decide yes or no for those sets of sides. Would they make a triangle? And then hit play to check your answer. All right, so let's go through part C. Can we have a triangle with side lengths of 2, 6, and 9? I'm going to say no, we can't. Okay, reason for that is 2 plus 6, the two shorter sides, have to be greater than the third side. Okay, in this case, that's 9. That is not a true statement. That is a false inequality. And what I have is one side that would be greater than the other two combined. Therefore, our triangle wouldn't work. Part D, same idea. Okay, we have a triangle with side lengths 4, 6, and 9. I'm going to say yes, we can. Okay, because checking those inequalities, again, you don't have to write this down, you just do them in your head, but we'll write them out here. 4 plus 6 is greater than 9, that is true. 4 plus 9 is greater than 6, and 9 plus 6 is greater than 4. Those are all true inequalities, so I know that, okay, this triangle would work. And the last question we're going to look at is going to be to come up with a range of possible values for a third side of a triangle, given that we know the first two. So problem 4, part A says two sides of a triangle are 5 feet and 8 feet long. What's the range of possible lengths for the third side? Okay, let's make a variable. Let's say that x is equal to the length of the third side. Okay, what I know then is that x can't be greater than the two other sides combined. So I know that 5 plus 8 has to be greater than x. Okay, if we add those together, 5 plus 8 is 13, so that means 13 is greater than x, or in other words, x has to be less than 13. Okay, now that gives me a maximum value for my x. Let's go ahead and find a minimum value also. For that, what I'll do is I'll put the larger of the two sides on the right side of the inequality. We'll say that we know that we have to have 5 plus x is greater than 8. So x has to be big enough to make 5 plus it greater than 8 here. That's a simple inequality to solve. I'm going to subtract 5 from both sides. And that'll give me that x is greater than 3. Okay, what I can do then is I can combine those two inequalities, those two answers, into a single compound inequality. We'll sandwich x between the minimum, which is a 3, and the maximum 13. Okay, so given side lengths of 5 and 8, x can be anything between 3 and 13. Okay, technically we could say x is greater than 3 and x is less than 13. There's our answer for this one. Okay, now one other thing with this, if I set my second inequality up wrong, we'll show you what we get for an answer. If I put the smaller side on the right side, we'd have 8 plus x is greater than 5. Now if I subtract 8 from both sides, what we'll end up with is that x is greater than negative 3. Okay, it doesn't really make sense to talk about negative lengths for triangles. Okay, this part doesn't make sense. So that's why we'll lose it. Stick with the positive answers. If you do set this one up, just cross it out, flip it around the other way, and get the positive answer. Okay, part B is the same idea, finding the range of a third side given two sides. Why don't you take a minute once again, pause the video, work through that one, and then hit play to check your answer. Alright, let's run through B quick. Triangle has side lengths of 4 and 7. What's the range of possible lengths for the third side? Well, if that third side is x, I know that 4 plus 7 has to be greater than x. Okay, because it has to be less than the sum of the two sides we know. 4 plus 7 is 11, so x is less than 11. All right, then also if I throw the bigger of the two sides to the right side of inequality, we can say 4 plus x has to be greater than 7. And I can subtract 4 from both sides. That'll give me that x is greater than 3. All right, so my solution then, my compound inequality, will put the x between the 3 and the 11. Okay, there's my range of possibilities. All right, so that's it for 5, 6, triangle inequalities. Okay, we'll build on that in the next lesson, show you some more stuff we can do with inequalities and triangles. Okay, but for now, start cranking on the homework, start getting some math problems done. Let us know if you need help, and we'll see you folks later.